Now, zeroing in on the bottom of the slide here, want to just make sure that we reiterate the idea that hopefully is familiar of this function notation. So we can write an equation in function form by replacing the y with f of x. And so we see this here. Instead of y equals x squared minus 4, it says f of x, or kind of we could read it as function of x. And so it's just a notation that really becomes pretty valuable in higher level math classes, but it shows up here in our Algebra 2 course, so we want to become comfortable with it. And so again, this isn't a linear function, but we're not limited to just having linear functions when we talk about functions. It's still the same idea where it's the y that is being swapped out for this f of x. And the key here, again, remember, is it's not f as some new variable times x. It's just the name. We're basically giving a name to the equation. So if we continue along, it may be helpful for us to kind of picture a function as a machine. So we've got input values, numbers that we're going to be plugging into the machine for x. So we plug in x equals 1, x equals 2. We can plug in anything we want. And then the machinery, the equation, does what it does to that input. In this case, we square whatever number we plug in, and then we subtract 4 from it, and then we generate an output. So whatever we get after plugging that number in for x, we end up with the output of the function for that particular value. So we get an input-output pair. We get an xy coordinate pair. And so the numbers that we plug into the function, those are our domain. We talked about that in the previous lesson. And then the output values, the numbers we get as a result of having plugged those numbers into the equation and generated the outputs, those numbers make up the range. So in the table that we see below, we've got 3 functions. So the first one here is this f of x equals 3x plus 1. And so just to start off with, for each one of these functions, we'll move on to the second and third ones in a moment, but we're plugging in just a value of x equals 2. We could plug in anything we want. We could plug in a negative number, we could plug in a positive, we could plug in 0, fractions, decimals, we can plug in anything we want. But in this case, we're going to just use x equals 2 as that number that we're going to plug in. And so you can see here that what we're doing is we're taking the x in f of x and replacing it with 2. So that's how we're indicating that 2 is going to be our input. And then right here, you can see that where the x was in that equation, 3x plus 1, it's now 3 times 2 plus 1. And so then we get 3 times 2 is 6 plus 1, 6 plus 1 gives us 7. And so we end up, for an input of 2, we get an output of 7. So there's our input-output pair for having plugged into this function. You can go ahead and try these next two before watching if you like, but I'll carry forward. So in the next one here, I'm going to do the exact same thing, but I'm going to replace x with 2. It's just that now I'm operating with a different function. It's now negative 2 over 2 plus 1. So if we do a little number crunching here, we've got 2 divided by 2, which is 1, but we still have that negative sign in front. So we've got negative 1 plus 1, and so we know that negative 1 plus 1 gives us 0. So our input-output pair, our input was 2 into this function, our output is 0. Moving on to the last example. So this time we have a non-linear function, since that x has an exponent on it of 2, but that doesn't change what our approach is going to be. It's just if we were looking at the graph or something, it would just not result in a straight line. But once more, I'm going to plug in 2 in place of x. So I've got 2 squared minus 3 this time. So 2 squared, 2 times 2 is 4, minus 3. And so 4 minus 3 gives us 1. And so our input-output pair is with 2 as an input into this function, we get 1 as an output. So this is just what we call evaluating a function at a particular value. So you'll see that in your homework. We're asked to evaluate a function for a particular value, and it could be any number that we want that we could plug in for x. And so then we're just trying to figure out what is the output that goes with it. In our last couple of examples, we're essentially working backwards. So in those problems that we had in the table in the previous slide, we were given an input to plug in for x, and then we were generating the output that went with it. So now we're being given a function here, so negative 2x plus 7, and now instead of being given an input to plug in, we're being asked to find what input will give us an output of 21. So right here it says that we want f of x, we want the output to be 21. So I'm literally going to take this and I'm going to replace f of x with 21. F of x equals 21, so I'm going to make f of x 21, so I'm going to replace that. And now I've got just negative 2x plus 7 on the other side. And so now I just need to solve for x. So this is what I mean by working backwards. So we're trying to figure out what number do I have to plug in for x to make 21 be our output. So if I'm solving a two-step equation like this, I'm hopeful that we remember we're going to undo our addition or subtraction first. So we've got 21 minus 7, so we've got 14 equals, still have negative 2x over here on the other side, and so now we've got to get rid of that negative 2 in front of the x, so we're going to divide both sides by negative 2, so that takes care of that, and so then we get x equals 14 divided by negative 2 is negative 7. So I would have to plug in negative 7 into this function to get 21 as an output. And I could go ahead and do that as a check if I wanted to. So if I plug in negative 7 for x, so I'm going to go negative 2 times negative 7 plus 7. And so negative 2 times negative 7 gives me 14. 14 plus 7 indeed gives me 21, which is the number that I was supposed to get as the output. So we can see that it works. For the last example, so now, and I think this is the first time in these notes that I've had a letter other than F there. Hopefully we remember that it does not matter what letter we use there. F is by far and away the most common, but it could be H, it could be G as it is in this case. Sometimes we'll see J or P. It just kind of depends on the circumstances. F is by far the most common, but we can throw any letter we want in front there. But this time we want the output of this function to equal 4. So I'm going to do the same thing I did up above. I've got 4 equals 3/4 x minus 8, so I've set my output equal to 4. And now I'm going to follow that same two-step process. I'm going to add 8 to both sides to undo the addition or subtraction. So that means I now have 12 equals 3/4 x. And then we never divide with fractions. Instead, we're going to clear that 3/4 by multiplying by the reciprocal. So I'm going to multiply both sides by 4 over 3. That's 4 there. And so that means that these two pieces cancel each other out. And then on this side, if I put that over 1, I've got a little cross-canceling reducing that I can do. So we can take out that 3 on the bottom. We can turn that 12 into a 4. So now we're just left with 4 times 4. And all we have left over here on this side is x. So we've got x equals 16. And so again, we could go through just like we did over here to verify that our answer is correct. Plug in 16 for x. 3/4 of 16 is 12. 12 minus 8 is 4. And so we again know that we've found the correct input. So this is just finding what input will generate some desired output.